Cats. We are going over the review for Unit 5. The unit is Chapter 2 and Sections 2 through 5. We're going to start with our quiz review 2.2 and 2.3, and the first question was about the right and left end behavior of your graphs. So let's talk through these 6 examples here. Alright, so the first one, remember we're looking at the leading coefficient. Make sure you're always in standard form and that your leading coefficient is the first one in the order it looks like. In this case it is. The leading coefficient here is, the leading term is in the right order. The leading coefficient here is positive. That would mean on the right we would move upward. And because we have an odd exponent, we would do the opposite on the left. So that means on the left we would move downward. And that would be the end behavior of our graph. For B, we have a negative leading coefficient. That means on the right we would go downward. And we have an even exponent. The highest degree is even, and so for we would be equal to the right side, so we would also be going downward. In example C, we have a positive leading coefficient. We would go up, and we have a an even degree, an even degree, so everything's will be even. We would also do the same on the left. In example D, we have a negative coefficient, so we would go downward on the right. Oops, sorry about that. And we have a even exponent, so we would do the same on the left. In part E, we have a positive leading coefficient. That means on the right we would move upward. We have an odd exponent. We would go opposite on the left. And finally, in our last example, we have a negative leading term. That means we go down on the right, and we have an odd exponent. That would mean we go opposite on the left. And that kind of takes care of our left and right behavior. Please make sure when we get to those really big problems where you're finding all of the zeros and the x-intercepts and the y-intercepts and you're graphing them, please make sure that you take into account your right and left behavior. That you do that at the very beginning, even if it doesn't ask you. That makes sure that you are graphing properly. And we're going on to the next problem. Alright, in this next problem we're asked to find the polynomial given the zeros. So we've given the solution and we're trying to go backwards to find what polynomial these solutions came from. The first step, we're going to take this in steps. Step 1 will be to write the solutions as factors. Write as factors. So we would take our negative 4 and write it as x plus 4. We would take our positive 2 and write it as x minus 2. And we would take our negative 1 and write it as x plus 1. So that's step 1. In step 2, we're going to multiply everything together. Okay. So let's go ahead and do that. Let's go ahead and do these two together first, and then we'll bring this one straight down in just a minute. So if we take these two, we're going to actually FOIL these together. So first times first, which would be x squared. Outside times outside, x times 1 would be positive x. Inside times inside, that would be negative 2 and x, negative 2x. And of course, last times last. Negative 2 times positive 1 is a negative 2. Combine your like terms, and we would have x squared minus x minus 2. And then we still have x plus 4 to distribute through as well. So let's go ahead and do that. So we're going to go x times x squared would be x cubed. X times negative x would be negative x squared. X times negative 2 would be negative 2x. Then go back and pick up the 4. 4 times x squared would be positive 4x squared. 4 times negative x is negative 4x. And finally, 4 times negative 2 is negative 8. And then just clean it up by combining your like terms. When we do that, we would have an x cubed. We took care of that. We have a negative x squared and a positive 4x squared. So we have a positive 3x squared. Took care of those. We have a negative 2x and a negative 4x. We have a negative 6x. And finally we have negative 8. And that would be our polynomial with the following zeros. Alright, let's look at another one of those. Part B of number 2. these are the zeros we're given this time. 1, square root of 4, and the negative square root of 4. Okay, remember, complex numbers always come in conjugate pairs. These are the conjugate pairs right here, a positive square root of 4 and a negative square root of 4. Now, technically, the square root of 4 is 2, so you could have changed this to 2 and negative 2, but we're going to leave it with square roots right now just to practice what would happen if you did not, if those weren't pretty numbers. Let's say they were 5s instead of 4s, what you would do. So again, the first thing we're going to do is write as factors. So we take our 1 and write as x minus 1. We would take our square root of 4 and write as x minus the square root of 4. We take our negative square root of 4 and write as x plus the square root of 4. And once again, I would take these last two and multiply them together. Now we've got a unique situation here because these are conjugates. So remember, for conjugates, the middle cancels out. That makes our work a little shorter this time. So we have x times x is x squared, and then we have to do just last times last. So negative times positive is a negative. Square root of 4 times the square root of 4 would just give me a 4. Alright, so now we have x squared minus 4, and we'd multiply times x minus 1. And we'd FOIL these. Alright, so first times first would give us x cubed. Outsides would be negative 4x. Insides would be negative x squared. And last would be positive 4. And if we put that in standard form, we would have x cubed minus x squared minus 4x plus 4. And that would be our polynomial given those zeros. Alright, go Bearcats. Let's move on. Alright, in these next couple of examples, number 3, A and B, we're going to find all the real zeros of the polynomial. That's sort of a hint to us that there may not be any imaginary solutions. If there are, we'll go ahead and find them, but I believe you're only going to find real numbers. Probably we can do this mostly by factoring when you have this situation. Remember a couple things that are important. If we were graphing, just to review that, the negative would mean I would go down on the left. The 4, which is even, would mean I'd also go down, on the right, which would mean I'd also go down on the left. A couple other things, we want to find our x-intercepts, and we're going to do that by factoring. I believe these both have a 6 and an x squared, and we're going to go ahead and take that negative out as well. So we'll take out a negative 6x squared, and inside our parentheses, this is one factor, inside our parentheses, then we would have x squared, and it would be minus 9, because negative times negative would give me back the positive 54x squared. Of course, this could be broken down one more time, so our factors really are negative 6x squared, and then it's going to be x plus 3, x minus 3. Now, the zeros from that would be 0, negative 3, and positive 3. But wait a minute, we thought we were supposed to have 4 zeros. Oh, and we do, because this x squared would actually occur twice. That could be x times x, so that would give us 2 zeros, and the value of those zeros is 0. So this zero is an x-intercept, and it has a multiplicity of 2. And if it has a multiplicity of 2, then remember it would bounce when it hit the axis. So let's just take a look at what would happen. Our y-intercept in this case is when x is 0, so that would also be 0. So our x and y-intercept are the same. We have an x-intercept at 0, which is a multiplicity of 2. I'm going to put a little x on there so I remember to bounce at that place. I have a 0 at negative 3, and I have 1 at positive 3. And we know we start down and we end up down, so let's see what would happen. We would go through the point, we would come up, we would bounce, we would come up, and we would go back to the point, and our graph's going to look something like that. Alright, go Bearcats. Alright, let's keep going to part B. Another one of these type of examples. In question B, we're given the equation, or the function, f of x equals 3x to the 4th minus 48x squared. Kind of a similar problem. Again, let's take a look at what would happen though to our graph. It's positive at the front, so we would have a graph going up on the right. It's an even exponent, so it would also go up on the left. Again, the y-intercept is when x is 0. It looks like we're going to have a y-intercept at 0, 0. Let's see if we can find some x-intercepts. Our x-intercept, again, it looks like they both have a 3 and an x squared, so we'll take out 3x squared. And then in our parentheses, we would have an x squared, and we would have a minus 16, which again can be broken down. So we'll keep our 3x squared as a factor. And then this will be broken down into x plus 4, x minus 4. So our zeros would be 0, negative 4, and positive 4. Once again, we're supposed to have 4 zeros, and we do because this x squared would occur twice, again, having a multiplicity of 2. So it's going to bounce. Make sure that you realize that. So at 0, I'm going to put a little x so I don't forget to bounce. I have a 0 at negative 4 and a 0 at positive 4. We start up, so we would come down. We would hit the axis. We would come back down and bounce. We would come up and go back straight up. Not straight up, it would actually go off to the side a little bit. And our graph would look something like that. That's a little messy. Sorry about that. All right, let's move on to the next question. Okay, once again, very similar instructions. We're trying to find all the real zeros of the polynomial, and we have the function that looks sort of like this. If I see a function like this, and I don't have a calculator, and of course we're in pre-cal now, we don't have calculators very often, I would clear out my fractions to make my problem quite a bit easier for myself. So I would take this entire function, and I would multiply everything by 3. When I do that, that clears out this 3, and I would have an x squared. Clears out this denominator's 3, and I'd have plus x. Clears out this denominator's 3, and I have minus 2. Again, before we go any further, let's look at what the graph in behavior would be. Positive at the beginning, I would go up. Even, so I would also go up. Notice this is a quadratic, so that's going to be pretty easy. Only one turn in a quadratic. We're going to factor this now that we've cleared out our denominator because we're just trying to solve. So we would have x and x, and we would have 1 and 2, and since we want it to be a positive, it would be a positive 2 and negative 1. And therefore our x-intercepts, our solutions, our zeros, would be 1 and negative 2. So we have one at 1 and one at negative 2. And our graph would look something like this. It would go up on the right, it would come down at some point. Now if we wanted to, our y-intercept, if you make all the x's 0, our y-intercept would be negative 2/3. So it's kind of a short little turn there. So actually this is kind of come down here and be kind of a wide graph at the bottom. And it might look something like that. All right, let's look at part B. Part B is similar, but it's going to be a little more complicated to solve. This function is f of x equals 1/5 x squared plus 8/5 x minus 2/5. Again, to work with this, I would clear out my fractions. And when I do, I get x squared plus 8x minus 2. But we get a little bit of a problem here. I can't factor this because I can't multiply to negative 2 and add to positive 8. So I cannot factor. Makes me a little sad, a little worrisome, but I have an alternative. I can use the quadratic formula, which we all know is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we'll use that quadratic formula and we'll get a little practice on that. So in this particular equation, our a value, if we're solving, is 1, our b value is 8, and our c value is negative 2. Put this in the quadratic formula. So we substitute in by negative b, which would be negative 8, plus or minus the square root of 8 squared minus 4 times a, which is 1, times c, which is negative 2, all over 2 times a, which is 1. That would be negative 8 plus or minus the square root of a number. That value underneath the radical is called the discriminant, and over 2. So let's go back and take a look at those numbers, that discriminant underneath. 8 squared would be 64. Now just kind of ignore x squared for a minute and think of this as a negative 4. Negative 4 times 1 is negative 4. Negative 4 times negative 2 would be a positive 8. So 64 and 8 would be 72, which would be our discriminant. It's positive, so we're going to have two real solutions, real solutions. And let's go ahead and be a pre-cal student and simplify our radical. So we're going to simplify the square root of 72. I'm going to go over here and do our little upside down prime factors. 72 divided by 2 would be 36. divided by 2 would be 18, divided by 2 would be 9, divided by 3 would be 3. All right, because it's a square root looking for pairs. There's a pair of 3's and a pair of 2's. That 2 comes out, that 3 comes out. Multiply those two together for 6 out of the house, and this little 2, no friends, it stays home. So 72 becomes 6 square roots of 2. Let's write that. We have negative 8 plus or minus 6 square roots of 2 all over 2. All right, let's do our last little bit of work with simplifying. We have negative 8 over 2. Remember, this 2 is a denominator of both. Plus or minus 6 over 2 square roots of 2. We'll simplify that. Negative 8 over 2 is negative 4. Plus or minus 6 over 2 is 3 square roots of 2. And that would be our final answer. Woohoo! Go Bearcats. All right, let's move on. All right. Our fifth problem is about long division, and we're doing long division. And long division does several things for us. I think we focus so much on the process we forget what it provides for us. It helps us find a 0 if the remainder is 0. It gives us another, if the remainder is 0, it allows us to have two polynomials, the one that we are dividing by, which is called the divisor, and then the one we find. If there's a 0, if it's a 0 remainder, then we have two polynomials multiplied together to give us our original equation. So in this case, since this is a quadratic equation and we're long division, this is a linear equation. We should find a linear equation. Let's take a look and see if we can do that. All right, so we think about the first term in each part, in the divisor and the dividend. So we have x and 5x squared. So x times something gives me 5x squared. I believe that would be a 5x. And 5x times x gives me 5x squared. And 5x times negative 4 gives me a negative 20x. And then remember, it's long division, so I'm subtracting everything. That means I just change all the signs. This becomes a negative, this becomes a positive. All right, these will cancel. We have negative 17 and a positive 20, so we have a positive 3x minus 12. Now we have x times something gives me 3x. That would be a positive 3. 3 times x, again, is 3x, and 3 times negative 4 is negative 12. But once again, we're subtracting, so change both signs. This becomes negative, this becomes a positive, and woohoo, this becomes a 0 remainder. All right, so now we have a linear factor here and a linear factor here. One thing that you want to note is that now x minus 4 and 5x plus 3, if we multiplied those together, they would give us our original equation, 5x squared minus 17x minus 12. So because x minus 4 was a factor, or 4 would be a 0, because of that reason, when we did long division, we also ended up getting our two factors. Our solutions would then be 4 and negative 3/5, and these would be your roots. Our solutions are on a graph, your x-intercepts. All right, let's take a look at another example. Example B. We're going to take x cubed minus 9, and we're going to divide by x squared plus 1. All right, this is a little tricky. You could actually, because you skip a degree here, you skip the squared and the x term, you could put 2 zeros in there for a placeholder if you choose to. That's up to you visually what you prefer to do. I'm going to go ahead and leave mine and just kind of squeeze them in, but you must be really careful when you do that. So now you're going to have x squared times something gives me x cubed. That would be an x. So x times x squared gives me x cubed, and x times 1 gives me just an x, and there's no x to put under, so I'm just going to put it right underneath, kind of in the middle. Since I have to subtract both, they both change signs. This becomes a negative and this becomes a negative, and I draw my line. These will cancel. This negative x squared, there's nothing above here, so this is just a negative x. There is nothing below negative 9, so this is minus 9. All right, this is actually a remainder because the degree is less than the degree of the divisor. So in other words, this is a first degree and this is a second degree, and because this is less, you don't multiply to get that. So x is your quotient, except that we do have a remainder. And since it starts with a negative, we're going to go ahead and say minus, and we're going to put the rest of this over our divisor. So x minus 9 over x squared plus 1. And that would be what your answer would look like. All right, let's go on to our last problem for this part of the review, and then we'll take a little break, and I'll come back with the second part of your review on a second video. Please remember, in any of these videos, I'm going rather quickly, so please feel free to pause and rewind and rewatch at any time. All right. These last couple of examples are using synthetic division just to practice that synthetic division. I also want to point out to you some of the things that we find when we use synthetic division. Synthetic division is similar to, well, the result gives you the same as long division. It's just a different method. So let's try example A. This is 5x cubed plus 18x squared plus 7x minus 6. And we're going to divide by x plus 3. All right, if we were doing long division, we would divide by x plus 3. Because we're doing synthetic division, we're going to divide by the solution, which would be negative 3. And that's what we're going to use for synthetic. All right, so let's go ahead and set up our synthetic division. I don't think we skip. Now, unlike long division, you have to put a 0 in synthetic division if you skip a degree, but I don't think we've skipped one here. We have a cube, a square, a first degree, and then a constant. So we've got 5, and then 18, then 7, then negative 6. And we're going to synthetically divide by negative 3. All right, we bring down our 5. And then negative 3 times 5 is negative 15. Negative 15 plus 18 would be positive 3. Negative 3 times positive 3 is negative 9. Negative 9 and positive 7 would be a negative 2. Negative 2 times negative 3 is a positive 6. A positive 6 and a negative 6 would be 0. Whew, we found a 0 right off the bat. Yes, that's my dog in the background. Hi, Frosty. All right. So what we have now is we've gone from a third degree polynomial to coefficients of a second degree polynomial or a quadratic. So let's take a look at that. So this would become 5x squared plus 3x minus 2. And we have found a 0. We can reduce our polynomial by 1 degree. And then if we were going to solve, we could go ahead and solve this quadratic either by factoring or by a quadratic formula. All right, let's look at B. We have x cubed minus 729, and we want to divide by x minus 9. Again, synthetically, we're going to divide by the solution, which would be 9. That's for synthetic. Long division, we just use the x minus 9. Okay, we're missing a lot of degrees here. Notice this. I guess I should say pick your eyes really big. We're missing a lot of degrees. Missing degrees. So make sure you sub in zeros. 0 placeholders. Need 0 placeholders. All right, so let's set up our synthetic division. We have an x cubed and the coefficient is 1. We're missing the x squared term, so that would be a 0. We're missing the x term, that's a 0, and then negative 729. Set up our synthetic division. And like I said, we're going to use 9 to synthetically divide by. All right, we bring down our 1. 1 times 9 is 9. 9 plus 0 is 9. 9 times 9 is 81. 81 plus 0 is 81. 81 times 9, believe it or not, is 729, and negative 729 would give us a 0, and what a happy camper we are. All right, so because we found a 0, now we have coefficients of our 1 less degree polynomial. We were a cubic, and now we'll be a quadratic at 1x squared plus 9x plus 81. Okay? All right. Hope you have a good evening. I'm going to go ahead in a few minutes and put the second part of the review on if you want to continue. If not, you can take a look at that tomorrow night. We'll work on just answering questions in class tomorrow, and then those 7 questions that we started on Friday. Hope you had a good evening, and I'll see you tomorrow, and be safe.